Hello everyone, it's September 18th. Alright, Saturday. I'm ready. Let's take a look. It's supposed to be a hot one today. Expression add operators. Oh. Okay. Given a string num that contains only digits and an integer target, return all possibilities to add the binary operators plus, minus, or multiply between the digits of num so that the result expression evaluates to the target value. What the heck? Yep, this is a difficult one. Ooh. You know what? Might not be. Maybe it's like, with first glance, it seems ridiculous. Alright, there are lots of questions. For example, is it every individual letters, or can individual numbers, or can the numbers be combined together? No, individual, because it's between the digits. So in between the digits, and I'm pretty sure it follows the rule. 2 plus, yeah, it follows the rule. Ooh, okay, so we have each place we have 3 options, right? And in total we have 10. We only have 10, so it's 3 to the 10th power. That's all different combinations. 3 to the 10th power is 59049. That is actually not that much. Honestly, that's not that much. Which means, you want to try? We can try. We can absolutely try it to just have all combinations, all possibilities, right? How do we iterate all the possibilities? Well, that's basically saying the first position we can do plus second position be. Oh, how do we do that? We have 10. We have X slots, and each slot we can do one of them. So, what would be the best way to handle this? That is a good question. What is the best way? I'm going to use eval, right? In this case, it's going to be eval, but I need to figure out a way. In the first position, the second position, I mean, what we can do. What would be a? I actually don't know. That's not combination. That's not combination. That's like each position we have 3 options. Each position we have 3 options, right? So let's say the first position we can have plus recursion. Here's recursion, right? So we say whatever the remaining, and then we just add 3 and then return. So we can get, and actually we can also, oh, that will all be stored in the stack. That's like a DFS search, right? It's like like a 10 level DFS search. So the first level I pick this, and then go to the next level, and that's into the last level. Then we will have the thing, and you know what? It's 59,000. 59,049, right? If we brute force it, let's brute force it. I honestly think we might have a chance to pass just by brute forcing it, simply because it's only 10. The length is only 10. Right? It's not that much. Let's brute force it first, and then we figure something else. So we're gonna say brute force. So we need to have def, let's just say helper. Right. What do we need? We need index and that's about it. And we don't have to return anything. Right? We don't have to return anything. So here we're gonna say, oh, a list of num. We need to insert something in between. How do we do that? Good question. How do we do that? We cannot split. I have to manually. So when you say list gonna equal to, it's actually gonna be this times, say, n equals len num, right? So this is gonna be times n plus n minus 1, right? So we have this, and then we're gonna say j gonna equal to 1, right? Oh, if its length is 1, that shall be a special case. Wait, what if length is 1? Do we return itself? Let's say 4. That shall return nothing. Yeah, if it's 6, what do we return? 6 by itself? Ah, it is by itself. So if n is equal to 1, then return this. If int num 0 equals target, else, no, not equal target. I would rather just say num, else this, right? So we handle that already. So j equals 1, I'm going to say for n in num, right? And we say list j minus 1 equals n, and j plus equal to 2, all right? So we're going to jump 2. Yeah, and then eventually j minus 1, and then j plus 2, j minus 1, and then we fit everything. Okay, so that's to get the list, and then we have index. So index is the first one, and then we always say if, right, if index, right, if index equals, so total is 2n minus 1, right? So if equals, I just do len list as plus 1 plus 1. So if index is equal to this, then we're going to say, what we're going to say? Then we're going to say if eval dot join list is equal to target, then exp equals this, right? And we say equals target, then res, and then we're going to have a result. The result is going to be this, then result dot append exp, right? Otherwise, we don't do anything. Else, right? Else, it's not n, so we're here. So I'm going to say for symbol in, we have plus, minus, and multiply. So symbol in them. I'm gonna say list index equals symbol. Then we do help index plus 2, right? Index plus 2. And then allow when it's done, backtracking. Oh, we don't even have to backtracking. So we're just gonna go back, change to a different, and evaluate again, and go back, change to different, evaluate again. When it's done, we're gonna go back to there. Yeah. So we're gonna say help 1, start from 1, and then return the rest. Okay, let's see. This is a weird brute force 6. Wanna have this. I'm gonna sort this thing. Next one, 232. Target is also 6. And this is the output. Oops. Next one, 5. Target is 5. Next one, 0, 0. Target is 0. Next one, whatever this thing is. Target is 9191. Return this. Of course, handle all this. This. Okay, so this is num. Target. Add num target, and this has to be, let's say, sorted. This equals sorted answer. We passed some, but we failed some. How? Something doesn't all right here. Something is not right. Oh, hold on. Hold on. I didn't notice this. Oh. Wow, okay. No. Now this is not going to work. Now this is not going to work. Because I thought it's each individual digit. Nah, it can't. Ooh. That is a different problem. Alright, no. And it's not. Alright. Nah, this brute force is not going to work. Now we have way more possibilities. It's not easily handleable, and actually we didn't handle it. Right? Some part is wrong. Like this one didn't give us anything. Actually, I'm curious why this one is. I know why this one is wrong, but this is interesting. Might we just print the list just to take a look? We have 2 plus 3 times 2. Yeah. This one is not. That is interesting. That is interesting. EXP. Actually, this is going to be EXP. EXP and eval EXP. Oh, wow. No mounches. This one. Hold on. 2 plus 3 times. Oh, I got it. It's 8. Ay. Dios mío. I got this one wrong. Okay, so this is not correct. Okay, so may we find something similar? No, I don't think that's. No, I think we need to figure something out. Something else. Like 1, 2, 3, right? Basically, we want to get a target at 6. what we can do is, now because we have a multiplication, now that is getting things complicated, right? Because multiplication will change the order of things. But what does not change is the plus sign. Like plus sign basically divided into two parts, right? Plus sign divided into two parts. And plus sign. No, hold on. Let's say we have a 1, right? At the beginning. There are many ways for this to be involved. It has to be involved, right? It has to be involved one way or another. It could be involved as its individual, right? As an individual. And then we're going to have to put one of the expression afterwards. Or it can be involved as 1, 2, right? Or it can be involved as 1, 2, 3. And we have to consider all situations because we don't know what this one is. So we have to consider 1, 2, or have to consider 1, 2, 3. Well, 1, 2, 3 might not because we can directly compare. If it's too big, then there's no way. So if it's considered by itself, that means if this is a minus, right, then whatever is in here, we can put a parentheses, right? We can put a parentheses. If it's a plus, we can put a parentheses. But if it's a minus and the parentheses within, the sign has to change, right? The sign has to change. If it's a plus, then we don't have to change the sign. So basically, if we put a plus sign, then we recursion on the remaining, right? Recursion on the remaining, we'll get different types of results, and then we go back to the first one and we check. Right? That's one way to go. If it's minus, then we still can do the remaining, but in the remaining, whatever results we compute, right? Whatever results we compute, we can do plus, minus, multiply, it doesn't really matter. Whatever results we compute, when we actually write it out, it has to be reversed. It has to be reversed. So it could be the same. And if it's a multiply, then we have the next value. Basically, we don't consider this one anymore because this is binding to whatever the next value is going to do. Right? It's going to be binding to whatever the next value is going to do. It's 1 times, so we'll go to the next value, whatever, then we have something, we have to times this. We have to times this. And yeah, that's what times will do. Well, that's the 3 situations, right? That's the 3 situations. It will be times something. So if it's a plus, then we do whatever. So we have a factor, right? That's a factor that we consider. A factor when we move on to the next one. So we have a factor, and then now we're pointing at this current value, right? And we don't worry about the factor. We would do all this, right? We do all this. Like we have a factor here, right? So when we are looking at the first value, we delegate remaining to compute whatever we need to compute. But when we compute the final result, right? The final result, which is at the beginning. I don't know if I like this idea at the beginning. But we can do at the end. right? We can do at the end, but that will be now it's easier for me to think at the beginning, right? Everyone, and then we delegate the rest. So in that case, we also need to cache it, because if we have 1, 2, and then we have figured out 3, and we can do 1, 2 separately, and then figure out 3. So we have to do it with a cache. So let's rewrite this. I don't have a very good idea, but we're gonna try regardless. Special case. Do we need special case to consider? Yeah, let's consider the special case. So here is what we're gonna do. Again, it's gonna be recursion, and we will have to cache it. Let's say import functool. Functool. Is that functool or functools? Don't remember. Functools. Tools. And then this one will be functools dot ARU cache. Right? And then this will be size equals none. Alright. We need a factor at the beginning, and current index, and that will be it, right? And this one will return a int, a value, right? So blah blah blah, don't do it, anything. So actually, it's going to return a list of int, because we might have more than one value. Return a list of int. So I'll return a list of int, and we're gonna check, right? Oh, hold on. We need to return a list of tuple where the first one is an int, and the second one is going to be the expression, or should I say str. So we need a tuple. So when we get out, so we're gonna say potential will equal to help. Started with 1 and a 0, right? And then, well, actually not. When you say for val, an expression in this, if val is equal to target, and then we return it, exp, right? So that's our result. All right, now on the right, the help function, the recursion. Edge case, where we at the end. Well, only at the end, apparently, if index is equal to n, right? That means we'll go to the end. And if it's that, that means actually think it through. Think it through. If it's at the end, what if we multiply? Right? Or if we multiply, what are we going to return? I think I need to think about the multiplication more. So what if I have the multiplication, right? And then basically that's a factor, right? We have a factor coming in. And if we have a factor coming in, what is going to happen is a factor, right? Just some value as a factor, and then coming in, and I'm just going to return. Yeah. So what if I want to times we do multiplication, and then we go to the next one, and what's the result? Do we handle? We don't handle, right? We don't handle that result. The result will be whatever the current one is. So if I times this, whatever this if I say it's going to be multiply, then my return will be you know what? I don't think we should do that. I think we should just end at the last one. End at the last one. No, we can. If it's the next one, and if it's a plus, right? If it's a plus, actually, I don't know. Like for me, I don't know what the previous one is. All I know is I have a factor, and if I return 0, right? If I return a 0, which means I have no value, and like if I have a factor that is, what value should I return? Good question. What value should I return? I mean, if I have a factor that's larger than 1, that means somebody has multiplied me, or maybe 1 multiplied me, right? Like 1 decides to multiply. Or we just have a rule that if we are at the end, we don't multiply. Then why don't we just have a rule as index equal to n minus 1? Yeah, what's the edge case? The edge case is we go to the next one, which we don't have, right? We don't have. Now, when we don't have the next one, if on this one we say it's a multiply, then right, because I don't know it's a multiply, then I come to me, right? What do I return? I should return just itself, right? I should return the factor. Return the factor. If it's going to be a plus, then I shall return a 0. How do I know that? How do I know that? Well, if I have a factor that's larger than 1, that means somebody must be multiplying me, right? That someone must be multiplying, try to multiply some on me, and then I shall return a 1. So I shall return the factor itself, right? That means it doesn't multiply anything. But if the factor is a 1, which means either 1 is trying to multiply, and if I return 0, that's going to cause an issue. But if I return 1, what if it's a plus? I think the end case has to be like, I don't know, like the end case is interesting. Yeah, it's very interesting. Like the current one, if I'm looking at the current one, if the current one is the last one, right? Then we should end here, right? Whatever is happening, we should end here. And like if it is a factor, then we just multiply, and it just factor multiply myself, and I return. That's it. And if I want to do multiple values, right? So wherever I am, I can always walk the way down. Yeah, so that's not, So we're gonna have a rule that we will not end past the last digit. So let's say at any index we have, right? we have a choice, either take it ourselves. So the choice is going to be for, right, for I in range from index, where I am right now, and then we just go all the way down, right, go all the way down. So from myself, and then we go all the way down until n, right, until n. And each one we can have the potential value. So current n, I'll just call it n, is going to equal to int num from index to I plus 1, right? I plus 1. This I is going to be indexed all the way to n, as at n minus 1. Yeah, so that's the n, current n, right? And then what we're going to do is we're going to say, right? We're going to say if I is not at the end, then what we're going to do is factor times this, and we're going to just do helper, the remaining, right? Help the remaining. And we're going to have 3 different scenarios. Right? I'm just looking at from myself, right? I mean, from myself, looking down, I have different scenarios. So when I need a result, right? I want a result for now. And what I'm going to do is for me is n, right? And I go all the way to I already. So it's going to be I plus 1 towards the end, right? Want to say, just edge case first. Let's say if I is equal to n minus 1, right? So if I already hit the end, right? If I is already hit the end, right? Then what I do is I'm going to take the end and we're just going to return it, right? We're just going to return it. So we're just going to return it. So that's only 1, right? So what is going to happen in this case? So we already walked towards the end, and I'm just return this chunk. This chunk is going to be put into the result, right? This chunk is going to be put into the result. How about the value? Right, the value will happen here. So when we say res.append, right, res is going to be appending a tuple, which is factor times n, right? And factor times n and n, strn actually, strn. Because I am the entire chunk. I'm returning the entire chunk. Right? I'm returning the entire chunk. Okay, so that's that, right? I have a factor comes in, multiplied to myself, and I return myself the entire chunk. Now, else, if I is not towards the end. Now, if it's not towards the end, then we actually need to call help. Help. It depends, right? It depends on what I want to do. So I can have current n, right? And I can have, different. So I'm going to say for symbol in, do plus, minus. Oh, we don't have this symbol. We just do it each way. So let's do plus sign. All right, plus sign, plus, and then it's going to be minus, and the last one is going to be multiplication, right? So if it's going to be a plus sign, so from my going on, it's going to be plus sign. So help factor is going to be 1, so I'm not multiplying anything. And the index is going to be I plus 1, right? So this one will return me a a list. So we're going to check every single one of them. So we say for val and expression in this, right? In this, now the value I am going to return. So when you say res.append, right? So the things I am going to return is going to be factor times n plus val, right? Plus val, because that's the result we have, like downstream. And I'm going to just plus them together. And the expression, that's going to be interesting. So we have an expression down the line. So what we need to do for this expression is going to be, let's just call it f, right? So it's going to be n plus, actually plus expression, right? So that's just current one, n plus expression. So that's the plus situation. Now minus situation. So same thing. Minus will be handled very similarly. A val expression, blah blah blah. And so this is not going to be plus. It's going to be minus, and minus the val. Whatever this is, minus the val. And here is going to be minus an expression we need to replace, right? Because we have to change the sign, which means we need to do some experiment, because I don't know actually how this one works. Right? So I think it's a.replace. Replace old and new. Oh, we have to replace every single one. Like plus need to be replaced to minus. Geez, how do we do that? Okay, let's say plus we're gonna replace with a this. And then that'll replace minus, replace plus, right? And then replace three level replace. And this is going to be this replaced with minus. Yeah, so this is what we're going to do. Reversed expression equal to exp.replace plus when replace with whatever, and then replace minus, right? Minus with plus, and so I'll replace this with minus. Right, so we can do this, and I'll replace. Alright, that's too ugly. I just put in one line, that's fine. And then there's going to be a reverse expression. Right? So that's that. So finally, it's going to be multiply. Right? Multiply is a little bit different. So if we do multiply, then we're going to have a factor, which is the factor times myself. That's going to be the factor goes in the next one, which means we're going to say for val expression in help is going to be factor times n and I plus 1. Alright? So factor times me, and then this is the new factor going to the next one, and whatever comes up, I think we can just use this, shall be sufficient. So when it comes back, the value is already computed. So we just need the value, right? I'm not sure actually. Do we just need the value? Let me think. I'm doing plus. I'm doing multiply, right? So this multiply the current one, and I said I'm going to multiply the next one, whatever the next one is. So I pass in, so I have a factor, right? And then I have a factor, and then they do whatever they want. Right? Whatever they want downstream. And then when they're done and return back to me, now I don't have to add anything because I already factored in. So this is going to be value. Right? So the downstream value will just be my value. And this is just going to be multiply whatever the thing is downstream. So that's that. So we do all that for everything, and at the end, we're gonna return res, right? And yeah, let's give it a shot. Actually, with this, I'm pretty sure we don't have to handle the special case because the special case shall be handled. I think shall be handled. We can actually try the special case. We can do 1, 6, that's going to be empty, and 6, 6, that will be 6. I run it. No, it's a max size. Oh, it runs for a long time. A long time. Okay, we pass some, we fail some. Let's take a look. So we get 1 times 0 plus 5. We get 10 minus. What the hell does 0 go? 1 times 5. That is not right. That is not right. What went wrong? Yeah, it took a long time, right? How does 1 is this times expression? Huh. So what happens is I take 1, I multiply with 0, and then 1 multiply. I need to see. Sorry, I need to see. Print res, print I, res, so we know where we are. Alright, just print everything. Alright, so we start with 5 and 5. Then we go to 1. 0, go to 1. 0 plus 5. The 1 we have at position 1, right? At position 1, we have 0 plus 5, 0 minus 5. Actually, I don't need, oh, that's fine. And then at 2 position, value is 0, and I have 5. What is this? What is this? Oh, this is, yeah, value is 0. And then 5, 0 plus 5, 0 minus 5, 0 times 5. That's a 0. Yeah. And what is this? I is 0, 1, 2. What is this? 5, 0 plus 5. Uh-huh. 0 minus 5. And we added a 5. What? Wait, what is this? We added a 5. That's here. We're looking at the last one. Right, we're looking at the last one. How? we add 2, right? I is 2. And then what I produce is no, it's not helping. It's not helping at all. Now I should print out n. That's what I should print out. Hold on, what's the value eventually I got? 1 times 5. I think what I have is 1 times, like 0 plus 5. I think this is what I got. Yeah, I think it's 1 times 0 plus 5. I added a parentheses. So basically I say it's 1 times, right? And then we handle a 0. That's going to be 0, because I times the factor, right? And then I plus 5. Okay? Then what happened? Then I still don't understand. How does how does 1 plus 5 come in? I also have 1 minus 5. Something with 0. Something with 0. So if I'm at 0, right? If I'm at 0 and I extend to 5, I think that's the problem. I'm at 0, right? And I take 0 by itself, which is fine. But then I'd extend it to 5, it becomes 0, 5. But I guess that's not allowed. Like we can say 1. Yeah, okay, they just use this. Yeah, I don't think it's like say 105, right? And I'm on 6. It shall give me 1 plus 0 plus 5. Or 1 minus 0 plus 5. But I cannot say 1 plus 0, 5. Because 0, 5 will evaluate to 5, which is not what they want. So, which means if I start with 0, then there's only one way, is 0 by itself. Huh. Okay, so that means we're going to check, right? I'm going to check if it's 0. Then, if it's 0, then we only have one range, right? So here is this. To n, if num index is not equal to 0. I like to say equal to 0. If it's equal to 0, then it's just index plus 1. Right, we can only move 1. Just can only include 0 by itself. And what if it's at the end? Yeah, which is fine. It could be at the end. It's fine. Because if it's at the end, then this will be the last one. Right? And then I will be the last one. Then we'll handle it here. Else, it's going to be n. And we pass. Yeah, it's the handling 0. So we're going to remove all the print. And actually, let's make it look nicer. Put it here. And put this one here. All right. Okay. Oh, let's run the rest. Take a time, and also 105. It's like a new thing we just got. Right, that's a new thing. So 105, 6, and this. I think this is correct, but I have fear that it might time out. Although I don't know why it would time out, because I have the cache, right? So factor is an integer. This is an integer, so basically it's an integer. I can just say from functools import ARU cache, and then here I just need to add ARU cache. All right, let's see. Let's see if we time out. Ready? Go for it. Pending. Judging. We got accepted. So it's just my laptop is slow. That's why we see a very bad time. More details. Not too bad. Not too bad. The limit is set to 7 seconds, and we got 28%, which is 1 second. So that's our. So okay. So this is just the DP solution, for sure. So what are we thinking about? So top down. This is a top down DP solution. We consider at each index, right? At each index of num, we have we can either take, right? We can either take the current digit by itself, or we can take 2, 3, 4, all the rest of the digits as a whole, right? As a whole. Once the current number is determined by including however many digits we want, we can add a plus, minus, let's say plus, minus, or multiply symbol afterwards. If it is a plus sign, we can immediately we can recurse on the remaining num, and whatever value the remaining computes, we will add the current number to it as the overall value. If it is a minus sign, right, we do the same procedure as the plus sign, except that we have to reverse. We have to reverse the plus and a minus sign from the expression of the remaining. If it is a multiply sign, we will pass a factor to the next round. This factor includes the current value as a multiplier for the next round. Whatever value returned from the next round will have already considered the current number. Thus, we just take thus we do not have to do anything. We don't have to do any more computation for the current value, current number. Now, there is one trick. There is one trick with 0. It can only be considered as a single digit. It can only be considered as a single digit. That's it. That is the trick. All right, time complexity. What the hell is a time complexity? Well, I mean, well, consider we do it 3 times, right? This is basically 3 times. So if we can figure out 1, we just multiply 3. Wait, do we multiply 3 or do we add 3? That's not multiply. I mean, this is multiply. This basically is just, and we are caching it, right? So each one is done only once. So if we can figure out the total number, which we can, right? So basically we have n-1 spots, right? We have n-1 spots that we can put, but we don't put in all of these. We're only putting some of these, right? So it's gonna be C. No, not C. I think it's P. No, it's C. C n-1, which is called a Cn. So n choose 1. N choose 0. So we don't need to put anything in. So n choose 0 plus n choose 1 and times n choose 1 times n choose 1 is the how many spots, right? And it's 3 to the n choose 1 and plus 3 to the n choose 2 plus all the way to 3 choose n to the, wait, hold on, no. N choose, no. It's n choose 1 as how many different we can do times 3 to the 1 plus n choose 2 times 3 to the 2 and n choose 3. So I think this is the time complexity, which is O. When you say n choose 0, right, times 3 to the 0 plus n choose 1 times 3 to the 1 plus n choose 2 times C times 3 to the 2 and plus plus n choose n times 3 to the n. I'm now going to simplify it. That's just the time complexity, I think. And our runtime is 1,000 and what? 1,094 milliseconds. We score at 28. It's not too bad %. Yeah, this is a good exercise, and we have a solution. All right, let's take a look. Backtracking. It's long. Oh, wow. Oh. Time complexity. 4 to the n. Maybe. What is t? What? Oh yeah, that's a good question. That's a good question. It should be more explicit. Leading 0 is not allowed. The complexity, I don't know. I have my way of thinking about complexity. All right, recursion. Oh, that's very long. I'm not sure if I want to read this. I really should. Oh, I didn't even consider this part, the stream building part. That takes on. So like n times this. Like, I mean, if I don't know, this is gonna be 1. I'm not really good at the time complexity thing. All right, let's read. Oh my god, that's way too long. Blah 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 blah. Each of the operators will require 2 operands. Right. Each of our digits as an operand. So in every pair of digits, we can have any of the 3. Sample digits and value of 5 is something. Yeah. Just had to consider those expressions as single digits. Yes, that's true. We can brute force it. A bigger number, exactly. Not really well defined. We tried all of the options. Yeah, that is, we tried all the options. Number of integer form from a substring of our original string. Yeah. All possible partitions of the given array. So they partition it first. Moved 1 step forward and extend the program by 1 digit. backtracking. Did I use backtracking? I don't think I backtracked. I mean, but it is interesting to think that we can partition all of them, and then we run all possible and eval it, right? That's one way to think. Evaluates, else, try out operand, and recurse, No op, just move one down, try this, and recurse, try this, and recurse, try this, and recurse. I don't have to, we can eval it. We can eval it. Yeah, I mean, just that will be straightforward, but we have multiplication, right? So multiplication, we have to handle it differently. I don't know how you handle multiplication. Factor, right? You have to have a factor as well. The last operand in our expression, how to modify the expression's value overall. Reverse effect. Okay, so pre plus 2, so plus 2, right? So now is multiply. So pre is plus 2, so the multiply, yeah, that's a factor, so it's going to be plus 8. Exactly. So previous this, previous is minus 10, plus the previous, nice. Okay, so addition. Now I'm not gonna follow theirs. I don't think it's just a lot of each digit will be operand, and we have n digits, n minus 1 operators, so on. We have 4 to the n, valid explanation. 4 to the n. 4 to the n. Maybe this one does add out to 4 to the n, who knows? Like, seriously, this might add out to 4 to the n. I don't know. I have no idea. And they're explaining. Okay, let's see. They're discussing the time complexity. Total number of valid expressions. T n minus 1, n minus 2 to t0. Total number of valid expressions times 3. Yeah, the total number of expressions. For 3 expressions, if we use first 2 digits as an operand, total number of valid expressions will be, yeah, so this equals this. If we put 3 times 4. Wait. So 3 times 3. 3 times 3 added is 3 times 4. Ah. Good analysis. Good analysis. Yeah. But how is mine wrong? Right? I don't think, because I'm considering the gaps. Right? That's what I'm considering, the gaps. Oh, technically it should be n minus 1 choose, right? Or you can say 3 to the n plus 1. Or maybe we're using different method. That's not. I don't think it's different method. I think it's the same method. And I don't think mine is easier. Easier to reason with. DFS with stack. Path is a string built so far. Value is current value, is current path. Last is the value of the last monomial. Hey, I don't know. I don't think I should read this. But they're also add the value on the fly. So temp is the current value, right? So they have temp, so the plus or minus the temp, and then they will do a negative, which is like the pre, right? And the last one. And how do we handle if the last one's none? We just do this. Else we have the last. So if it's a plus minus, it's all fine. If it's a multiply, that's when they do it differently. They do minus last plus last times temp. So what the last is, that's actually the factor, right? That's the factor. So last times temp. Okay. And then minus last and plus last times temp. This I don't understand. Yeah, the path, we add this, get the current value, right? As the current value, and then we handle the value, right? We handle the value, which is just plus temp. Then if this, we add it to it. I'm adding at the end minus times. Why don't we do the minus last first? We need to update both value and last should be multiplied. Yeah, that I understand. But why you do value minus last? It's like times last times temp minus 1. This is the part I don't understand. Pass plus multiply. Oh, shoot. All right, red alert, red alert. Something is happening. I don't understand his solution on this part. Why do we minus the last? So the last one is value from the last. Now we did read, right, if it's a if a current is a multiply and whatever the previous, right, is the last one, you need to times the current one and plus. You know what? Let me try his. And let's see if it runs. Unexpected indent. Yeah, that's very unfortunate. It does pass everything. What? Well, we don't have that situation. Wait, why do we do the minus again? Minus value, well, minus last, and plus. I mean, that's what I think. Just plus. Nope. Nope. You have to do minus last. So don't do it. We update the last element in stack. One, 2, 2, 3, 12, 60. This time we need to create a new temp. Make sure that that is a valid number. Next one we're going to use that if last equals none, I'll have one option, and then we have 3 options. Yeah, we just update value and sign. Are we handling a sign here? This basically says, hold on. Are we handling the sign? So the current, we're gonna add a multiply, right? So whatever value we have in the last, let's say if the last is a positive value, right? And then the last will be this. agreed, which is a fact, the next one. And then we don't just add this plus this, we also minus the last. Oh, I see. Because previously I already add the last. But now I need to remove the last and then add the current one. Ah. Yep, makes sense. Makes sense. Yeah. Your code is easier to parse than the official solution. Right, we can post ours, which is I think it's different from the traditional method. But the time complexity, I'm not sure we're doing it right. So, however, the official solution says the time complexity is 4 to the O, 4 to the N. And actually, let's just make it, it's going to should be N minus 1, right? Every N shall be N minus 1. So we're going to just do minus 1 time complexity. I believe in that than my time complexity. Although I don't think mine is wrong though. I mean, it's a choice, right? It's maybe these two equal. Anyway, so let's put ours, because what we do is a top down, right? What we do is a top down. I think memory wise, we might spend more time. Not more time. We spend more memory. I don't know. Memory wise, 239. Yeah, I think we are around 239 megabytes. Oh, memory wise, we're way out of the league. That's because we're saving every single one. Space is pretty bad. That's the benefit of backtracking, right? That's the benefit of backtracking. You go all the way down. This, in my case, yeah, but space complexity is pretty bad because we evaluate after all the recursion is done, which means all expressions must be kept in memory. The official solution evaluates at the end of a DFS, thus does not have to save, does not have to keep, and backtracks. Thus, it does not have to keep track of all, doesn't have to keep all expressions in memory. Yeah, it's a better one. I might write it. How would you name it? Well, I can name it non-backtracking, right? This is what we have. It's a non-backtracking method. Yeah. You can say non-backtracking method, but with bad space complexity. And all right, so this is our solution. And we have actually one more. All right, let's try to write the backtracking. Now that we have gone through it, it'll be difficult to produce, huh? So backtracking, so we kept every single one, right? And we need a last value, and then we keep tracking everything. So result, sure. N equals line nums, sure. So that's that. Def DFS, right? So we need index. We need index. So we need a value. So pre-value. Just called value. So we have index. We have value, right? As we go down every single one. And what else? What else do we need? Well, we need to also have the last, right? So the last can be integer. And expression, which is going to be a str, right? Expression can be a str. But this is going to return nothing, so we don't have to do anything. So blah blah blah, right? So after that, we're going to call it DFS. We start from 0, value is 0, last is 0, expression is nothing, right? We call it DFS, and then we're going to return res. Okay, and oh, that would be easier if we use a list. I think we can use a list, it will be easier. Yeah, I'll just use a list. Yeah, so if index equals to n, which means we go to the end, and I'm going to say if val is equal to target, then res.append this dot join expression, right? Else, okay. Else index is not equal to n, so index one of the values in between, and then what we're going to say is for, right? For, we can copy this, right? For I in range, for index to the plus 1 if it's a 0, right? Because a 0 can only do 1, or else to n. And then we're going to have n equal to this, right? So n will equal to this. Let's do strn or do n. Yeah, that's fine. I just do n. So that's n, right? So we have the current value. Now we have 3 paths to go, right? I have 3 paths to go, which is one path is for everything. One path is the previous, right? We'll have a previous expression with a coming in, so we can add a plus, we can add a minus, we can add a multiplication, right? So what we are going to do is the previous one. So we're gonna say DFS, right? I'm gonna do I plus 1, right? I plus 1. So the value is gonna be the previous value, right? We're gonna do the plus. So previous value is gonna plus the current value, and once we do that, the last does not matter, right? Because the last is the last, doesn't really matter. So we just do plus, and then it can be n. Last is going to be n. And expression is going to be exp plus plus and strn. In that case, maybe it's easier just to do str. Yeah, I mean, in this case, it'll just be str. And then we can just exp, right? So this is just going to be plus and n, right? So that's with a plus, and then with DFS the exact same thing with minus. Then there's going to be minus, right? And then there's going to be minus. The last one is going to be multiply, right? Multiply. Now this is interesting. So for multiply, which means whatever the previous one we already added, that one cannot be added. So we have to minus the last, right? To remove whatever has been added before, and then plus last times n. And then next one, the last times n. That's like the factor going to the next one, right? And expression going to be multiply. Once we do all that, boom, 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 we hit everything, and that's it. And we run this, and then return this. All right, let's take a look. Solution 2. Cannot concatenate because that's supposed to be this. Ooh. What the hell? Huh? What is this? We have a plus sign in front of everybody. That is not right. Because the expression value plus, value minus. But the expression is how do we handle this? And we have a lot more that's not supposed to be there. Interesting. I mean, we can do, which is like a no, that's no. Oh, like if index is 0, right? If index is 0, that has to be a different situation. If index is 0, then we don't do value stuff, right? That's basically it. So what we do is if index is a 0, we're just gonna be n. Yeah, index is 0. So what I'm saying is, if index is 0, that will be very different, right? Very different recursion. So we don't do this. So we have this. We say if index is equal to 0, then we're gonna hit very different, right? This is very different. And then else, index is not 0, we're gonna do this. So if the index is 0, everything, this should be n, right? Ooh, what about this? Last, that's all n, right? And this is all n. And expression is just going to be n. That's our starting point, right? So this is trn. That's our starting point. Oh, it's all the same. It's all the same. That's all three is the same. So now we pass. Now we pass. So this is oof. So this is according to the official solution, but based on the Backtracking. So I'm gonna copy the link. That's what this one is. We now see what this one is. Yeah, because the starting point is different. Yeah. The order of recursion is different. It considers what has happened before, and then what will happen when the current digit or number, the current number is included. Current number is included. Solution 1 is given the current number recurse to find what the rest is going to generate. So two different ways of thinking, different ways of handling recursion. But this solution, which is DFS, has a space advantage because it does not have to store all intermediate values in memory. Yeah, so that's that, and it's quite simple, honestly. One important trick is handling multiplication. Note that we do val minus last plus last times n, which means we remove the effect of last in the previous evaluation and add the new effect, which is last times n. Right, so that is the trick. And of course we have the trick with 0 as well. Okay, this one might run faster because it does not have to do the string replace. Right, that one takes some time. Alright, let's see. Ew, take a while. 616. Right, that's fast. 616 milliseconds, or what? Yeah, I don't need to make the ranking. My cat just by my side. He's very cute. All right, that's it. That's it for today. We did pretty well. We handled this. Is it difficult, right? I didn't even check. Yeah, it is difficult. 282. All right, so that'll be it. I will see you guys tomorrow. Adios.